currently responsible for information security at Reliance Jio, a new 4G player over in Navi Mumbai. That's launching later this year. But what I'm going to talk about now is coming out of my research lab in Germany, Berlin. So it's not connected to Reliance, but it's of course related to the topic that we're all working on. And what I want to bring to you today is the idea, and in fact show you how that idea could be a reality, of an attack that is so deeply rooted in our systems that we don't anymore know how to get rid of it. So it actually nicely ties in with the last talk. How do you exchange attack vector IOCs, right? Assume that's all taken care of, but now you know you had an attack hitting your systems. And you know the people who developed this attack, the capabilities that I'm going to show you today. Knowing that you were hit is basically the end of your job. You know you can never recover from it anymore. And that's what we're going to talk about today. Infection of computer system, persistent infection from USB peripherals. Can we switch on the screen? And this is probably the only time you'll ever see me use a Windows computer. So this is my demo laptop. And I plug in this USB device, standard USB thumb drive, as you can buy it in any store here. And of course, we know that USB thumb drives can carry viruses and whatnot. This one in particular, though, is completely empty. And in fact, there's no hidden files either or anything. And to make that point, let me just completely wipe it. So a 32 gig thumb drive just formatted, right? So this is where the virus scanner would just give up. There's nothing to scan here. Nothing can possibly happen. And some of you may have read about this research, obviously, since we had talked about it for the last 3 months. So even though it's an empty stick, watch what will happen next. Right. So this just turned into a USB keyboard, started typing commands very quickly, right? Opened a shell, downloaded something from the internet, executed it as a PowerShell command, right? This computer is now persistently infected. Persistent in the sense that this virus that was installed in Windows started infecting other USB peripherals right away. So I can put in another USB peripheral, and that will carry the same virus as this. Not every single one of them. There's a custom and vendor-specific component in the attack. But the chip that's in here alone is 20% of the market of USB peripherals, of which, of course, these thumb drives are a large share. And we'll talk through this through the next couple of minutes about how big this problem could possibly become. I should emphasize that this is, of course, research work, and we have not observed this anywhere in the wild. So this is a warning call for everybody who is operating infrastructure that people would want to target with advanced attack skills. This is not a warning about an attack that's already in the wild. Right? We call this idea of infecting computers or maliciously affecting computers BadUSB. Usually trust turning something bad. And I want to quickly go through the entire story and perhaps leave a couple of questions here and there. I'll be here for the rest of the day, though, at the reception and everything. And I'm happy to answer more questions and show more demos. That's what this computer is here for. We saw how this is happening. But before going into more attack cases, let me first explain what the USB standard was set out to do. And you'll quickly understand that this standard was basically made for attacks. Now, nobody consciously put it down as such, but they left out everything that could possibly be considered secure. When a USB device is first seen by the computer, they go through kind of an introductory phase. As soon as the USB peripheral receives power, electricity over the port, it sends a hello message to which the computer, kind of like a DHCP server, responds with an address. And then the peripheral shares its descriptor. It would say something like, I'm a keyboard. This is called a human interface device in the USB lingo. Or it would say, I'm a video device, like a webcam, right? But it can say, for instance, I'm a video device, but I'm also an audio device. You know, most webcams have a sound card built in, or microphone built in, right? So the standard allows a peripheral to be different things from the off-start, right? And that's very useful in cases like webcams. It's very useful for composite devices, things that are connecting to serial and Ethernet and VGA, for instance. That's a typical composite device. And then the computer loads the appropriate driver, and they start communicating. And here's the next clue why these attacks work so well. The USB device is allowed to change its mind, right? It can later on say, wait a minute, I'm not a webcam anymore, I'm something else now, right? It can re-register. And again, that's useful. Am I running out of battery here? Yeah. That's useful for cases like 4G modems. You plug in a 4G modem, it shows up as a CD-ROM. You install the device driver, it changes its opinion, now it's a 4G modem because you already installed the driver, right? So the people who created the standard, they were well intended. But of course, this is terrible as a security technology. Plug something in, and it can be anything in the world, and it can even change. A colleague of mine put it, I think, the right way. He says, USB is a hole in your computer, which literally is the case, but also metaphorically, right? It's a big gaping hole. So USB devices can turn into something malicious if they can be reprogrammed. And that's the big question. Can USB devices be reprogrammed? And what would be reprogrammed on a USB device is a chip that you probably have never been aware of. If you plug in a storage device into your computer, you know there's some big flash chip somewhere that you store data on. But how does the data... Sorry, I scared the people in the back. How does the data get onto this flash chip? Obviously, a flash chip doesn't speak the USB protocol, doesn't know anything about the computer. So there's an intermediary, this chip, that's a fully programmable computing system, very small, obviously, but it has a processor, it has memory. In fact, it even uses a small part of the flash chip as its hard disk, and that's where the USB protocol runs from. And since it's fully programmable, it's also fully reprogrammable in the field by somebody malicious who gives you a USB device, or even by your own computer after that was infected with a virus from the internet or wherever else, right? And how much effort is it to reprogram these things? The first time we tried, we took about 2 months. So the chip in here, the one that you just saw here, took us 2 months, going from knowing nothing at all to creating all kinds of attacks on it. And this went mostly 3 steps. First, we needed to understand what protocol this speaks. And in the USB standard, there's no such thing as a reprogramming part. So every manufacturer, in fact, every chip vendor, comes up with their own ideas. That's quickly reversible, though, by just Googling for firmware update and the name of the chip. You'll find, usually on Russian websites, actually, some reflash tools. You then go through an actual firmware that's also attached to these reflash tools to understand what it's supposed to do. Nobody's going to give you source code for this. You have to work with binaries. And for those people who do reverse engineer, these are binaries in 8051 code with no symbols and even unknown memory mapping. So there's quite some work in there to understand even what it's supposed to do. But once you understand that, you can quickly add functionality. Your hook function is what it's called. So in the middle of some existing function, you jump into an empty space of code where you put your malicious code, execute that, and you jump back to where you came from, right? So pretty quick fix. 2 months total, starting from nothing at all. The second chip then, for instance, in this one, this was the second one that we reversed, that took us maybe 3 weeks then, right? So you get faster over time. And we'll talk in a minute or two about how many chips there are that you would need to reverse engineer. Now, given this capability of reprogramming USB devices, what all becomes possible? And I'm probably just scratching the surface here with the few things that we implemented, but that already should be scary enough. We saw a USB device infecting a computer. I told you the computer can now infect the same USB device, in fact, different ones. These USB devices can infect different types of computers. Created a variant for Windows 32 bits, one variant for Windows 64 bits, one variant for Linux systems, at least most flavors. We even created a variant for Mac, which we had to take out from our demos because I ended up infecting my computer a couple of times. So this spreads very quickly, and it's very generic. So now we have a multi-platform virus that spreads with no help from the internet. Right? So you can imagine all these SCADA systems that people have to carry their software updates to with USB devices becoming infected and infecting each other, completely air-gapped systems. Right? Imagine Stuxnet using this. The Israelis, Americans, whoever did it, they could have saved a couple million, didn't need any Windows 0 days. So what else becomes possible, though? We're not limited to keyboard, and in fact, keyboard may be a much too obvious way to attack a computer. The second stick, we infected such that it becomes a network adapter, okay? And then the network adapter spawns a DHCP server, still running on the chip, and the DHCP server assigns an IP address, obviously. It also assigns a DNS server on the internet, but it doesn't give you a gateway. I don't know if that was a little bit too technical, but basically what it means is this USB device tells you to use your existing internet connection with a different DNS server. Right? And if you control DNS, you control everything somebody sees on the internet. Right? You can redirect all traffic. And if it's not HTTPS protected, you can change all traffic. Right? From just plugging in a USB device. Right? And that's not limited to storage either. In fact, we released code, like a 5-line script, to get this exact thing implemented on an Android phone. So next time somebody asks you, can I charge my phone on your computer? Right? That's a USB connection. It could very well be that they're redirecting your entire internet traffic. And this is not, I cannot emphasize this enough, using any vulnerability as in a software bug. Nobody did anything wrong here. When they first wrote a USB standard, this was a feature. Everything can become anything at all. There's no way of knowing. Right? So we all sign up to that when we made USB popular, and now we got to live with it. What other attacks are possible? This is certainly not limited to desktop or laptop environments. This is relevant for cloud environments as well. At least the dingy cloud providers that I'm using, whenever I ask them for more storage, they just plug in a big USB disk. Right? I want 10 more terabytes of storage. Give me a USB stack and connect it to my virtual instance. Right? I can reprogram that SATA controller, the USB to SATA bridge, right, to then spawn off another device. That other device is connected to the host. So through USB, I can break out of my virtual machine. Right? So I don't know how common that is to connect USB to cloud instance. But just don't do it. Right? Even if you trust the USB, your tenant may start reprogramming it. Right? Then you don't trust it anymore. We implemented one interesting attack, again on this older stick, to get around any type of software protection. We implemented a detection of whether we're connected to Windows, Linux. We needed that for the other attack. And we added the component, we know when it's connected to the BIOS during boot. Right? So when it is connected to the BIOS, we switch over to another thumb drive, a much smaller one, that Windows or Linux can never see. We don't show it to Windows. And we also emulate a keyboard. On this computer, press F8. What does F8 do? Boot from alternative devices. In this case, from this new USB storage disk. So it boots from the USB disk, takes about 3 seconds. You don't see anything on the screen, it's just black. During those 3 seconds, it goes into the Windows partition, changes a bunch of files, can even change the registry, and then boots Windows. Right? So we infect Windows while the Windows software is not running. Right? No way to fight this with a Windows-based antivirus. In fact, no way to fight this with anything that looks like an operating system, because the malicious part of the stick will just stay silent. It doesn't exist. That storage disk only shows during boot. Okay? So these are all the attack scenarios. And as I said, these are only the ones that we implemented and scratching the surface here. You can be anything at all in this USB world. Just be creative, become a screen to capture a captcha, for instance, or anything at all. So when we presented this as Black Hat, so these next couple of 2 slides, 3 slides are actually new material. When we presented this at Black Hat, a lot of people got really scared, but some said, no, this is not a USB bug, this is a vendor bug. You cheated. Well, and we kind of did. We looked at 2 different chips, but both of them came from the same Taiwanese company, right? Saved us time. So people said, you didn't find a bug in USB, you found a bug in Phison, this manufacturer, right? So we went back to the drawing board and tried to understand, this is really just affecting Phison, 20% of the market of storage, or is this much bigger than that? And what we found is the answer is somewhere exactly in the middle. We did 2 analyses. First, we went through hundreds of data sheets to understand what USB controllers are there in different types of devices, and which of those are technically reprogrammable. Some of them never are, they're just made custom purpose. Some of them are very reprogrammable and always will be, and some fall somewhere in the middle, where you can keep them reprogrammable or switch it off. And then we looked at actual devices, 30 or so, that we actually opened and started reprogramming them, all kinds of different devices. And in both of these analyses, we find that something like half of the devices are reprogrammable. On this top-down analysis, reading the data sheet's a little bit more fuzzy, so all the red stuff is definitely reprogrammable. The yellow stuff, the manufacturer gets to decide, and the green stuff, there's no bad choice. And you see it varies kind of by device class. But even a benign thing like a USB charger sometimes is reprogrammable. So imagine plugging into a charger, infecting that charger, so that everybody who, after you plugs into the charger, gets infected again. Right? Crazy stuff, but not hard to pull off. And we went basically all categories. You can infect a computer, like the USB controller, inside the computer, to then infect the computer again after you reinstall the computer. You can infect the webcam that's often built into the computer. In this Mac, I have an SD card reader on the side. That's connected over USB. So in this computer alone, there's 4 chips, all connected over USB, of which probably 2, just by these statistics, are reprogrammable. So next time I have a virus on this computer, basically I have to toss it out. I don't know whether I can ever recover from this vulnerability. And this goes through all categories. Again, I can't emphasize this enough. This has not been seen in the wild. This is a call to arms for those people who protect critical infrastructure. Sometimes it's, even on a chip level, extremely hard to tell whether it is infectable or not. This is the same chip in 2 USB hubs, right? This one is not reprogrammable. This one is, because they put a little storage chip next to it. So you have to go pretty deep in your analysis and open these devices and do all kinds of research to understand whether the USB stuff that you are using is potentially reprogrammable. And once you know, it's probably changing. People start swapping out these chips like crazy. This exact same looking USB thumb drive we found with 5 different vendor chips inside. Right? So basically you have to open every single device, read the chip marking, see the configuration, is there a flash chip not, to understand whether this is potentially carrying a virus that a virus scanner can never detect. Right? Do you start getting paranoid? And I certainly, after thinking about this for a couple of months. So to wrap it up, after 3 months of public discussion on this topic, no good defense has emerged. Some people say, oh, just disable USB keyboards, but then we come at you with an emulated network card, and they disable that, and then we emulate a touchpad, and so you end up on that route disabling everything USB. That's not going to help anybody. The cost of not using USB is probably higher than the cost of having the virus on some of your computer. Critical infrastructure side, I think USB has no place in critical infrastructure. So people try to fix this through software. They say, why not just extract the firmware from the device and compare it to a known good sample? Well, catch one, who has known good samples of USB firmwares, right? They keep changing all the time, too. Catch two, in order to extract the firmware on the device, you rely on the help from the firmware. So the firmware can lie about what it is, right? No way of knowing. It's not like a storage disk that you can just read. Kind of like a boot sector virus in the good old days that changed the operating system in such a way that you can't read the boot sector virus anymore. This time, though, it's built in. So no solution has emerged yet. And even worse, nobody even feels responsible for this problem. As I said earlier, nobody did anything wrong. This is how USB was designed to work. The chip vendors say, well, just buy another chip that's not reprogrammable, right? Because there's so many choices. The people who do buy the chip say, well, not our problem, right? Why don't they fix the chips? The operating system vendors say, we implemented this exactly as it's in the standard. If you don't like it, use something else. Use Bluetooth, right? Use SD cards, right? Connected over USB, of course, in most computers, right? So it seems like nobody has acknowledged this as their problem yet, which tells me it's not going to get solved, right? At the same time, in parallel, though, people are implementing these attacks. So this research was only released exactly 3 months ago. But since then, I've seen 3 talks at 3 other conferences where this has already been put into action, where people recreated the results, started attacking devices. So it only took weeks for them to implement. Right? And that's just the researchers who do it in their free time. Who knows about all those criminals, right? So this is coming at you, and nobody seems to be working on a fix. Usually I end on a positive note with a talk, but this time I'm really blank. So thank you very much. This was BadUSB, and it will come at you. Thanks.